Okay, we're going to do a chi-squared goodness of fit test on the calculator. So we've got the null hypothesis that the birthdays are evenly distributed, and the alternate hypothesis that the birthdays are not evenly distributed. So what we need to do is we need to add this time a list. We can put into our list the frequency, call that one F, and the expected frequencies I'm going to call E. Label those two. Type in the data into the list. 12, 14, 18, 17, 15, 15, 14. Double check and verify your data to make sure you've not typed it in wrong. And then add your expected values. Now to find the expected values, in this case, we can find the total number of students and divide it by the number of days of the week, 7. That gives us the 15. So once we've entered the data into our lists, we want to find the chi-squared statistic. We do that here. We press menu, statistics, stat tests, and then the goodness of fit is number 7 there. Chi-squared goodness of fit test. We need our observed list. Our observed list is the frequencies, and our expected list is E. We also need to calculate the degrees of freedom. So the degrees of freedom in this case is the number of rows or columns. In this case we have 7 columns, so rows or columns, minus 1. 7 minus 1, we got 6 degrees of freedom. We have 6 degrees of freedom on this one. This gives us a chi-squared calc value equal to 1.6. So to conclude the test, we can use the critical value, and in this case we've got 1.60 is less than 12.592, which implies that the chi-squared calc value is less than the critical value. That means the amount of variation in the data is within expected boundaries. So in that case, we therefore say that there is insufficient evidence to reject the null hypothesis. Which implies that birthdays are evenly distributed.
So what do we know when we accept it?
We don't accept the null hypothesis. We either reject it or we have insufficient evidence to reject it. So we either reject the null hypothesis.
If we would have found the last line, that means we could have accepted
If the amount of variation in the data was much higher, the chi-squared calc value would be bigger than the critical value. And in that case, there would be sufficient evidence to reject. And then categorically, we would state that the birthdays are not distributed. But in this case, there isn't that much variation, which means there's insufficient evidence here to reject the null hypothesis. So it implies that quite probably the birthdays are evenly distributed.